start with the session as we have already quite waited for everyone to join in. So we respect your time and we'll start with the session because you have already joined up and we really appreciate you to joining our session and we hope that you get good knowledge out of this session. So thank you so much again for joining us today and for taking that time out of your schedule. It's very important and we are greatly thankful for that. On behalf of the Catalyst Group, it's a pleasure to host such a knowledgeable group of industry professionals who are closely involved in driving efficiency, quality, performance in ethanol operations or beyond. We really appreciate your performance and the services that you provide to the industry. And we really hope that you do keep on doing so that our industry grows and we are able to contribute it professionally. We affirm on our commitment that Catalyst has also successfully completed 23 years now. And we really appreciate that the colleagues have helped us out, the company, the team. We sincerely thank for all the support that we have got throughout this long and meaningful journey. The client's trust has been really cornerstone for our growth. We really appreciate it. Thank you so much, everyone, for joining in. Today's session focuses on understanding where sulphite originates, why it matters, and how it influences fermentation stability, yeast health, and overall ethanol performance. We will also discuss practical plant level approaches that can help improve the outcome. Since you have been dealing with a lot of issues and the things that are quite common in the industry, we like to appreciate that and we also see that where we can help out you guys and the clients and any industry professional who is facing this problem. This would be a very interactive session, so we hope that you get knowledge out of it and we hope that this webinar is quite meaningful for all of you. So we request all of you to be on mute during this session and whatever the questions that would be there with you, please kindly note it down during the session and we'll take the questions later on as soon as the webinar is over with the session by Dr. Pavan. We'll take the chats at the end. We'll also discuss that whatever the questions would be. And let's get started and introducing the speaker of the session. So it would be my pleasure to introduce our speaker for today, that is Dr. KVTS Pavan Kumar, Vice President R&D QA and QC Group. Everybody, it would be a humble request to please be on mute. Thank you so much. Dr. Pavan is an accomplished biotech professional with over 20 years of experience in R&D and development. He has a strong track record in developing sustainable biotechnological solutions across agricultural, bioenergy, genetic engineering too. He is known for his expertise in translating research into commercial viable products that have met industry needs and has successfully grown Catalyst Group and also delivered complex biotechnology projects from ground up. His passion for research is reflected more than in his patents that have been around 10 plus and more, and numerous national and international publications and awards. Dr. Kumar spent over a decade with a Swiss-based multinational company before taking on the current role, where he leads the research and development efforts at the Catalyst Group. So we introduce Dr. Pavan with you. Over to you, Dr. Pavan. And thank you so much once again, the whole professional and the industry experts who have joined into the session. Thank you so much. Over to you, Dr.
Good evening all. Thank you very much for joining the session, and without taking much time, I will move to the current today's topic. As you all know that we are facing lot of challenges in the fermentation, especially in the ethanol fermentation process. But some of these things are known to us, some of things are visible to us, and certain challenges are not directly visible to us. Only the effect will be visible. So the sulphite or the sulfate problem is one such problem which is not directly visible to us when we do the fermentation, but its impact only we are able to see. So today we are going to understand along with you how the sulphite is, from where the sulphite is coming from, and then how it is impacting our process, what kind of measures we have to take to analyze it, because the current today's challenge is also on the analysis part. We do not have proper tools and techniques to analyze it with accuracy. So we are going to touch upon that analysis part, as well as what kind of mitigation plans we can take so that we cannot eliminate it, as we know, but how do we mitigate the challenge that we are facing in this particular ethanol fermentation, mainly because of sulphite. So hope my screen is visible to all of you.
Yes, it is.
Okay. So as I mentioned it to you, today our topic would be on the sulphite, which is the hidden challenge in ethanol fermentation. So sometimes we see that our fermentation is not going smooth and we will not be able to find out the reason. So one such scenario and one such kind of challenge would be maybe because of sulphite. Before going into it, let us first understand what is the source of the sulphite in ethanol fermentation. There are a lot of sources from where the sulphite can come into the ethanol fermentation. But especially if we can try to categorize it and then try to see it, the first source from where the sulphite can come into ethanol fermentation would be from the upstream process. The upstream process is basically our sugar manufacturing process. As we all know, sulfitation is one of the common step in the sugar manufacturing, and then we use sulfur dioxide to do the sulfitation process to clarify the juice in the sugar mills. So when we use this sulfur dioxide for the clarification process, most of the sulfur which we are using will not be used by the material or the process, and some of these things will get remained in the streams. That means the carryover residual sulfur dioxide will go into syrup, juice, and even it can be forward to the molasses. So this is the major source from where the sulfur or sulphite is coming into the picture. Apart from that, when we look at it, the next one would be because of certain practices that are being used at the plant. Sometimes we may face some kind of operation. Sometimes we face operational challenges. I would request all of you kindly mute, please. So some practices we also reason for this sulphite. For example, when the plant was stopped and there was a storage of syrup which we have to do in between, so we may use certain products knowingly, unknowingly, which are from the source of which is having sulphite, like sodium metabisulfate. These kind of products, when we try to use it, these things will also introduce sulphite into the process. And the next one is, as I mentioned it to you, the molasses, especially the sea molasses, which is highly concentrated byproduct of sugar industry, will be having a lot of these sulphite carry forward residuals. And this will also be more in case of the plants where the mill to mill variability is more and the sugar, we are using excessive sugar loads or we are doing double sulfitation. So the sulphite levels will be more in such scenarios. Apart from that, when we look at the processed water and recycling streams, so if we use these recycling streams which are already having sulfides and sulfide residues, this will also add to the current scenario. It will add more sulfide to the existing process. So condensate reuse that we do, which is already having sulfide residues, is also, or it could be a reason for sulphite introduction into our ethanol fermentation. Other than this, we may also use certain products, chemical inputs, basically to control the process, or maybe as an additives or process improvement products in our sugar manufacturing or maybe fermentation, like the anti-scalants and then cleaning agents, additives, which are based out of sulfur. So this will also create a challenge in terms of introducing the sulphite into ethanol. And inadequate rinsing after CAP. So certain products like SMBS we use normally for the cleaning or CAP process. After that, if we properly do not rinse it, so it will add all these sulfides to the system. Other than this, operational factors like accumulation due to repeated recycling streams, if we start recycling these streams again and again over a period of time, these sulfides will be accumulating in it. Not only sulfides, other byproducts also will accumulate, but in case of, as we are talking about sulfides, these sulfides will be accumulating in it. And then uh, another challenge would be we do not have proper monitoring systems at the plant. So this is also lack of these routine sulfite monitoring systems at the feed points also could be a reason for this sulfite introduction, as we do not know how much it is going in and coming out. So basically, if we look at it, these are the sources from where the sulfite can enter into our fermentation. And let us see how this is going to impact our process. As we all know, yeast is our organism which is producing alcohol for us. How it is getting impacted. So little bit, we'll go into a little bit of science, and after that we will also see how we can relate it to the effects which we see at the plant. Normally, if we look at it, sulfite exists in equilibrium in these three forms: SO2, HSO3 minus, and SO3 minus 2. So if it is in the neutral pH, mostly it will be like HSO3, and if it is shifting towards acidic pH, it will get converted into SO2, and if it is more towards basic pH, it will be like SO3 minus 2 form. SO2 form is more toxic, as it can easily enter into the yeast. So let us understand what is happening when sulfite is present, how yeast will behave. As we all know, yeast will not understand from where it is coming. So what it will do is, whenever the sulfite is present, yeast will think that it is something like toxic or something which is undesirable for it. So it will try to remove it from the system. When it is trying to remove the system, it is not a simple process like just take it and then throw it out. Normally what will happen is, inside the yeast there are certain genes will get expressed. That means, as we all know, if we try to correlate this with the dosing pumps and other things which we normally see at the plant, if I have to dose it, I have to dose a product, normally I will switch on the dosing pump. I will switch, I will on the switch. The similar way, there will be certain switches on the yeast cell wall. Those switches will get switched on when SO2 is present. So especially if we see, there are switches like SUL1, SUL2. What it will do is, whenever there is a high sulfite is found in the medium or in the wort or in the fermentation broth, it will immediately gets on, and it will try to take the SO2 into inside the yeast, so that yeast will see that okay, outside it is not there, so it can work. But during this process, yeast is supposed to produce ethanol, but its focus is getting diverted towards something else. Basically, instead of producing ethanol, it is trying to take up this sulfur dioxide and then, or sulfite, and then try to eliminate it. In this particular process, it will consume, or it will use more energy, it will consume more sugars. So this is an unknown loss which we normally miss to evaluate or analyze or measure it. The similar way, when the more sulfite is getting accumulated inside the cell, yeast cell, there will be another switch which will get switched on, and it will try to throw it outside. Like SSU1, FZ1, F1, these are the switches which will get switched on when more sulfite concentration is present inside the yeast. So they will get switched on, and it will try to throw it out. One particular pump or one particular switch will try to push all the SO2 inside the yeast cell. Another switch will push it outside. So this process will be continuously going on and on and on, which will consume more yeast energy, and then yeast focus will be diverted, so that it will not be able to fully focus on ethanol. So this is what it happens inside the yeast when the sulfite concentration is increasing in our fermentation process. Apart from that, if we see, this is the basic ethanol producing pathway. In this particular pathway, it starts from glucose and then comes to pyruvate. Up to pyruvate, we call it as energy producing process. But in the anaerobic conditions, especially like ethanol fermentation conditions, the pyruvate slowly it will produce ethanol. But when the sulfur dioxide concentration is more, what it will happen is this acetaldehyde, which will get bound to the sulfite and it will form 1-hydroxyethane sulfonate. So what it will do is it will bind with the acetaldehyde and it will try to throw it outside the cell. When this happens, the acetaldehyde, when it gets bound to the sulfur dioxide, the low acetaldehyde concentration will make an imbalance, especially if we see the red color indication here, NAD plus and 2-NADH. This particular mechanism will get imbalanced. It has to be balanced. When acetaldehyde is pushed out of the system, the NAD/NADH metabolism will get imbalanced. Because of this imbalance, cells will think that there is an imbalance and I have to balance it. So yeast, what it will do is it will try to produce more glycerol to generate this NAD/NADH balance. So instead of producing ethanol, the pathway will get diverted towards glycerol. That's where we see that more glycerol production and then yeast is coming under stress. We call it as yeast stress में आ गया है और glycerol ज़्यादा produce कर रहा है. So this will also makes yeast confused. So what it will do is it will keep on trying to produce glycerol and it will try to keep on producing acetaldehyde, but this particular pathway will not be moved or pushed forward to ethanol. Because of that, we will be facing ethanol losses. Apart from that, the sulfites also inhibit certain enzymes which are very important in the ethanol production, like alcohol dehydrogenase ADH, which because of which the alcohol will get reduced, and pyruvate decarboxylase. This enzyme inhibition will create acetaldehyde production imbalance. So this is the whole mechanism or the genetic mechanism or the enzyme mechanism or the protein mechanism pathway which is happening inside the yeast when sulfite is present in the fermentation system. So let us see what kind of parameters will create more challenge or it will actually add to the fuel. We say that adding to the fuel, right? So the similar way, which parameters will aggravate the सल्फाइड टॉक्सिसिटी, जो सल्फाइड टॉक्सिसिटी है इसको ज्यादा क्या क्या कर सकती हैं. So if we look at these kind of parameters, the first parameter would be pH, low pH specifically, and we all know our fermentation will be running between 5.5 to 3.5 to 5.5 pH, and we can consider this as a low pH or maybe slightly acidic pH. So in these pH conditions, what will happen is it will create the SO2 will become more permeable. That means permeable means it can easily enter inside the yeast cell and it will create inhibitory effect on the yeast mechanism. Temperature is also another parameter which will aggravate this sulfite toxicity. So the more the temperature goes up, it will easily allow SO2 to enter inside and it will also create oxidative stress on yeast. High free SO2 concentration is also another challenge which actually inhibit the enzymes. As we have discussed, the enzymes like ADH and acetaldehyde imbalance will happen because of high SO2, free SO2 concentration. Apart from that, as we all know, we are making only ethanol, but this ethanol also create more, it will support sulfite and then it will create more damage to the yeast cells. And because of that, we can see a synergistic toxicity, increasing toxicity on the yeast. Other than this, if we look at it, the nutrients deficiency also a challenge because as I mentioned it to you, yeast focus is getting diverted and it is trying to take out the sulfite. It has to consume more energy, more nutrients are required. So in that scenario, if we have less nutrients in the fermentation media, it will also create more challenge. Apart from that, we know that without sugar we cannot do fermentation, but this sugar also will add to the stress. And sensitive yeast, another important point is the yeast strain, whether it is really able to tolerate SO2 or it can withstand these kind of synergistic stress that is happening because of all the above parameters. That also matters a lot. So when we are selecting the yeast, if we select the yeast which is not resistant to this sulfite toxicity, or which is more sensitive to this sulfite toxicity, it will create problem, and we could see the results in the fermentation. So apart from that, yes, the fermentation time and age also matters. If we try to do any recycling of yeast, and then if we try to run the fermentation for more time, these particular impacts will be very clearly visible, and we will lead to huge losses. So till now we have seen the scientific aspects, and then what kind of parameters it is creating challenge when the sulfite is present in the system. So if we look at in the layman language, or if we simply say how we normally talk in the plants, what kind of impact we will be seeing when the sulfite stress is more. The first thing will be the yeast cell membrane will become fragile, and because of that yeast viability will be decreased, so that we could see lot of dead yeast cells. So one of the reason why we are seeing more dead yeast cells would be because of sulfite. And we will also be noticing slow or sluggish or sometimes stuck fermentation because of the sulfite stress. Obviously, when the yeast focus is diverted, we will be seeing lower alcohol yields, and the RS will be remaining at higher levels, so which is actually a loss for us. Apart from that, the carbon flux will also shift. So whatever the yeast is supposed to produce more ethanol, but the pathway is diverted towards more glycerol and other organic acids. So carbon flux shift, what we say in scientific language, but it is more of producing the other byproducts. So weak yeast dominance, because of this additional activity, when yeast is supposed to do only ethanol, but it is also doing other additional activities to ensure that it is survived. Because of that, the yeast will come under stress and it will become weak. Because of that, whenever the yeast is weak in our system, immediately the contamination will get increased. So this will pose to higher contamination risk. Normally, yeast can tolerate below 100 ppm of sulfite levels, but even 10 ppm above this 100 will be a big create a big damage to the fermentation process. Above 100 ppm, even if it is 10 ppm more, that means if it is 110 ppm, it could cause potentially 0.2 to 0.4% alcohol loss. And it will also lead to higher steam consumptions due to reprocessings, and then long runs it will increase the enzyme dosing, it will extend the fermentation cycles, the fermentation throughput or the plant productivity will come down, and there is a elevated risk of batch to batch variability. As we all know, majority of our plants ethanol will go for blending in the EBP program. If the sulfite levels are more in the final alcohol, it will get rejected. So there is a elevated risk of batch rejections in case if we don't tackle it, this particular challenge. So we have understood from where the sulfite is coming, and then how it is impacting yeast, and how we can see that impact in the fermentation process. Now let us discuss about the monitoring of sulfite concentration. How actually we can monitor or measure or analyze the sulfites. There are a lot of methods which were given, but I have listed few important ones which are feasible, and then which has its own pros and cons, but the major ones we will be discussing, and we will also give you an idea where we can use what. So if we look at it, the iodometric titration, this is the this would be useful for routine plant monitoring, but it has a limitation of lot of interference. So if we do the titrometric method, and then if we try to analyze it, it will give us a rough indication for the routine monitoring, but it will not give us the accurate values because it has low accuracy levels. And the other components which are present maybe in the wort or maybe in the fermentation broth or maybe in the syrup will interfere with this titration and will give us false readings. So we have to be little careful when we use this particular method. The next method would be Ripper method. This method will be for a quick syrup or wort checks we can use. It is a fast and simple method, but it is less accurate. It will not give us a very accurate results, but it will give us a quick and dirty method where we can quickly check how much free SO2 is present in it. The third method is Monier-Williams method. It will give us the total SO2 concentration. Mostly this will be used for the validation, audits and disputes, but it is a very time consuming method. Only skilled people can do it. Even the skilled people, matlab, the people who are continuously doing this analysis day in day out also will get variations in their analysis. So it has to be done very carefully. So that's where it will be used only at the time of disputes or maybe when they want to critically audit the process. During that time, the Monier-Williams method will be used. Other than that, we have the advanced technology like ion chromatography. This will be more useful for the laboratories like R&D research laboratories and the other labs, advanced labs. Due to the high capex, it will be very difficult to manage it at the plant, as well as we also need skilled operators to run these particular machines to do the analysis. And apart from that, we also have the sample oxidation risk in this particular process, which may give some false readings at some times. Next one would be UV visible spectrophotometry. I would say that this is the best method in the current scenario where all the plants can start using it. It can be easily implemented. It has good sensitivity, and then it can do both free as well as total SO2 and SO3. It's mainly used for the quality labs where we need ppm level accuracy. So by considering the current scenarios and the cost and the level of operational complexities and other things, UV visible spectrophotometry method is the one which we can adopt at our plants. Other than that, we have sulphite test kits, and many of you must be knowing that there are lactic acid monitoring kits. With the same kit, we can also monitor these levels, but it is again fast, and then it is only just to take quick decisions, and it is a semi-quantitative method with lower accuracies. So we cannot completely rely on it. And then the variations in terms of keeping the sample and then sample time and then analysis time will also give us false results in this. So it has to be used with a lot of attention. So if we look at it, all of these things, all these methods which were described here, UV visible spectrophotometry is the one which is more reliable, and with less capex cost we can implement at our labs in the plants. So coming to the next topic or the next subject will be on this sulphite mitigation strategies. So as we understood how to measure it, now once we measure it, we have to take actions in terms of mitigating it. As we could see from the source, the main source of sulfites is from the upstreams. So we have to see how we can prevent it from the upstreams. The most effective method is this one. By minimizing the sulfite dosings in the sugar clarification, we can do it. I won't say that it is like we have to compromise on the sugar clarification process, but we have to use it diligently so that it won't impact the sugar clarification, as well as it will not leave a lot of residues in the byproducts. And the next one is process neutralization using lime. Again, we have to ensure that lime dosage should be controlled, otherwise it will create unnecessary other challenges. Apart from that, controlled aeration is another strategy which can be used. And as we all know, in the molasses preservation or molasses tanks, we keep running the circulation pumps. One of the reason why we have to run the circulation pumps is the remains or residues of the sulfites which are present in the molasses will get slowly oxidized and will enter into the atmosphere and leave the molasses when we do this recirculation process continuously. So this will recirculation will not only help us in terms of making the molasses homogeneous and then avoiding crystallization and helping us in cooling down the molasses temperature. Apart from that, this is another reason why we have to do this recirculation, so that any remains of sulfite which is present in the molasses will get slowly oxidized. Apart from that, we can when it comes to the syrup fermentation, where we have to use sulfited syrup. Another strategy many of plants has adopted is mixing it with the juice and then fresh juice or mixed juice to reduce the concentration of sulfite in it. This methodology was tried and tested and very well adopted across the plants. So these are the upstream prevention process which we have to take, and this is the main focus which we have to, or more the main emphasis we have to give here. Coming back to the next step, we know that we cannot avoid completely, so we have to take precautionary measures. In that scenario, we have to ensure the yeast strains, whichever we are picking it up or which we are using it for the fermentation, are tolerant for this sulfite. If it is tolerant for the sulfite, we will not see much impact on the fermentation process. Apart from that, we also need to increase the nutrients quantity in it. As I mentioned it to you, the more stress or more energy yeast has to spend in terms of sulfite, so it needs more nutrients. So we have to additionally supplement nutrients to yeast so that we can minimize this particular sulfite toxicity. Apart from that, there are certain enzymatic and biological detoxification processes are in process. They are emerging technologies. Still they are in the research phase. I hopefully it will take a few more years to come into the market, but these are currently under exploration. If we look at it, the streams in terms of how much should be the limit, typical SO2 limits in the streams, if we see in the juice or mash which is being used for the fermentation, the ppm level should be less than, in between 10 to 15. And if we take syrup, it should be 20 to 25 ppm. In molasses, less than 50 ppm. Fermentation broth, it should be less than 10 ppm and it should be free of SO2. If it is mixed with SO2, more free form is available, then it will create more damage to yeast. So we have to ensure that it is less than 10 ppm, and in animal feed and distiller solubles, it will be allowed between 50 to 100 ppm. In final ethanol or distillate, preferably it should be less than 5 ppm. The regulatory norms are less than 10 ppm, but it is better we keep it less than 5 ppm so that it will be useful for us. So these are the strategies, mitigation strategies which we can do at the plant, and other than that, even these mitigation strategies are not completely working and we could see that still there is a scope for improvement. In that scenario, we can use certain products which can help us to mitigate or which can scavenge the sulfite from the system. So one such product is sulfotreat, which is the scavenging or detoxification product which can be used in the fermentation process to reduce the sulfite stress. If we look at the mechanism or the process, how it will do, the sulfotreat components, the product components binds or neutralizes the free sulfite molecules. What it will do is it will bind to the free sulfite so that it will not allow it to enter inside yeast cell. By doing this, it will reduce the toxicity on the yeast and it will prevent the disruption in the metabolic pathway. So if SO2 is not entering inside the cell, then the metabolic pathway will not get disturbed, enzymes will not get inhibited. So yeast will perform normally. So the sulfotrit S will work majorly on detoxifying this by scavenging. Scavenging in the sense it will bind to it and it will remove it. Next one is protecting the, it will also protect the yeast by stabilizing intracellular conditions. As we understood that once SO2 enters inside the yeast cell, it will destabilize the entire mechanism, metabolic pathways. But the components of sulfotrit S will try to help to balance it up to some extent. So in that way, it will try to help yeast and it will reduce the oxidative damage and maintains the yeast viability. So this is what that sulfotrit is going to do to yeast. It will remove the, or it will scavenge the SO2 molecule. It will try to protect the yeast. And the third one, the visible indications what we see in the fermentation would be the fermentation process will improve with respect to the pH. As we know that when sulfite levels are more, we could see rapid drop in the pH levels in the fermentation wort. So it will improve the pH based on the trials what we have done till now. What we could see is there is an improvement of 0.1 to 0.3 pH and a very good gravity fall improvement. It will reduce the fermentation time. Normally, if in presence of sulfites, it will take more time for fermenting it and to reach the final gravity fall. But with presence of sulfotrit S, the fermentation time will get reduced. It will also enable higher CO2 and ethanol production. As you all know, the toxicity is eliminated. It will help to yeast produce more ethanol. So when it is eliminating the stress, we can see this shorter lag phase and then smooth fermentation. We will not see the stuck or sluggish fermentation there. It will also reduces the sulfite levels in the final ethanol. So our main challenge currently we are facing in the industry is remains of the sulfite in the final ethanol, because of which a lot of batches are getting rejected. So it will reduce the sulfite levels in the final ethanol. So this is the important thing which the sulfotrit will do. So let us discuss few case studies, one or two case studies which were conducted using the sulfotrit. This is a plant where they are doing the syrup fermentation, and then we received information from them that their fermentation time is increasing, and then fermentation is getting stuck, and they could not eliminate the sulfite in the final ethanol. Our team, technical solutions team, has analyzed the various process conditions, and then finally they found that the syrup is having more levels, sulfite levels, approximately 900 to 1200 ppm. So it is actually negatively impacting the yeast, and then pH is rapidly getting dropped. Fermentation kinetics are changing, and because of that, a lot of time is taken for completing the fermentation cycles, and the efficiency is getting reduced. So when we have observed these parameters, we suggested them or we requested them to try the sulfotrit, and then when sulfotrit S was applied in the syrup, when they are getting when the syrup is coming from the sugar manufacturing process to the distillery, in between there was a day tank. In the day tank we have dosed this particular product, and then after that it was taken into the fermentation. Approximate time that was given for this is around 30 minutes retention. So when these doses were optimized and then implemented, we could see a good outcome in this particular plant. We could see with respect to the sulfite level 72 to 74% reduction, and then pH was improved by 0.1 to 0.3 units. We have observed a faster gravity fall compared to the control batches, which is indicating improved yeast health. And if we quantify the time that was taken for fermentation with respect to the control batches, we could see 5 to 6 hours reduction in the batches which were used sulfotrit S compared to the control batches, and more than 50% sulfite reduction in the final wash, and the fermentation efficiency was around 85 to 86%. before using the product, and after using the product, the fermentation efficiency was increased to 90%. And wash pH was also improved from 4.1 to 4.8. And the final ethanol sulfite levels in the final ethanol was below 5 ppm. So this is one case study which we could do with the help of the plant, and then we could achieve the desired outcome, and we could control the fermentation timelines as well as the productivity, and we could also achieve the final target of reducing the sulfite levels in ethanol below 5 ppm. The next case study is there are a lot of batches. This is from another plant where the ethanol batches were getting rejected due to high sulfite levels. As we all know, it should be below 10 ppm, but they are getting more than 10 ppm. When we did the raw material analysis and then process audit, we found that their molasses is having a huge amount of sulfur. So we have identified the root cause, and then because of this, the ethanol specs are coming out of the specification, and a lot of commercial losses were observed at the plant, and their operations were disrupted. So we suggested them to try a sulfur-free test, and deployed the target sulfur mitigation solution there when it was dosed in the fermentation tank post fermentation. So here they have some challenges with respect to adding it before fermentation, though we suggested them to use it during fermentation or before fermentation. They insisted us to use it post fermentation. So after completing the fermentation, we have dosed it in the beer well or maybe in the fermentation tank. So by giving 8 to 10 hours retention in the fermented wash, when we used 100 ppm dose, we could achieve 37% sulfur reduction, which is bringing down the sulfate levels to 10.66, but still it is more than the desired level. So we have slightly increased to 200 ppm. We have increased the dose from 100 to 200 ppm, and then we could achieve these sulfite levels below 10, which is 6.7 ppm. So it is a below rejection limit. So the problem was resolved. So the ethanol quality was restored, and the elimination, we have eliminated the rejection risk. As I mentioned it to you, so this product can be used at various places, but we recommend it using it before fermentation or maybe during fermentation, so that the dosages will be consumed less, as well as it will get enough retention time for the product to act on the sulfite. But post fermentation, as we know, the ethanol is already formed, and then a lot of byproducts will be there. So due to this interference, the product efficacy will be slightly reduced. So we have to dose at higher dosages. If we can do this, probably if anyone have any doubt or any reservations on this, probably we can do a lab test first, how it is working in the fermentation process, and based on that we can start using it. So these are the two case studies which I would like to present it to you, and then I would like to emphasize that the challenge which we are seeing, which is almost like a hidden challenge till now, can be resolved by using these kind of solutions. So you may be having doubts in your mind, like what could be the reason for the challenge in my plant, or what is causing these kind of challenges. So don't worry, we are there, and we are with you from past 23 years, and we will be with you for next coming years, as we are working together as a family, as a Catalyst family. We always stand with the customers, and then we are customer centric company, where we will give you the complete support. We will not just sell the products or the solutions, we will give you the complete solutions. So with the solutions, we are with you. Our team has a very good technical, it is a very big technical solution team. I would say more than 70 people are working on the ground to help all our customers with respect to improving their process, and then streamlining their process, supporting our customers. So if you have any doubts or any challenges, please reach out to our team. Our team will do the complete raw material analysis, and then they will also conduct the lab scale application support. They will do the plant scale scale up from the lab to plant, and they will also conduct the free technical audits to make you understand, or to understand where it is going good. It is not only identifying the faults, it is also to give you an idea where the process is going good, as well as where we can do more improvements, and as well as data mining and product suggestions, the product suggestions, dosages, where it has to be used, how it has to be used, as well as on-site process troubleshooting. If you have any challenges or anything, we can help you with on-site process troubleshooting, and then product suggestions, process optimization. So all these things can be done by our technical solutions team. So don't worry, if you have any challenge, please remember to call Catalyst. So these are the glimpse of our R&D infrastructure, where we have all the required advanced instruments like gas chromatography, HPLC, as well as NIR, a lot of microbiology, molecular biology setups, and we also have the lab scale fermenters. So with the help of these equipment and infrastructure, before bringing any product into the market, we will do all the trials in multiple times in replicates to ensure the product works well at the plant. So thank you very much for your patience, and open to the questions.
Thank you so much, Dr. Pawan, for this great session. We really appreciate your time and that session that you have provided. I hope that was very knowledgeable and has given a lot of guidance and strategy planning for everyone to get to. And everyone, thank you so much for joining this session. We are open to discussions. We are open to the questions if you have any. The first question that has come up from Mr. Giri is from slide case 2. Dr. Pawan, since sulfur is required for yeast growth, could you please clarify whether the mentioned sulfur reduction in the case 2 refers to sulfide reduction only? Sir, your voice is not audible. Sir, you are on mute. Kindly unmute yourself.
Okay, thank you.
So
So the question is, since sulfur is required for yeast growth, could you please clarify whether the mentioned sulfur reaction in the case study refers to sulfite reduction only? Sir, sulfite is not exactly 100% required for the yeast growth. Yes, of course, there are certain amino acids which are sulfur based or sulfur containing amino acids, but the quantity that is required is very minimal. So additional sulfur की जरूरत नहीं है. And the coming to the next part of your question, where you are asking the reduction levels. Yes, the reduction levels are if it is more than the tolerable levels. Coming to the next question, which I could see in the chat box, the sulfite which ppm level is tolerate the catalyst yeast? The catalyst yeast can tolerate anywhere between 100 to 200 ppm. If it is more than that, then we have to use the other strategies.
going to the next session, sulfur is also used to control the wild yeast.
Sulfur is also control the wild yeast. Sir, whether it is a wild yeast or any yeast, sulfur precisely that would be the one reason why we use SMBS before doing the CIP or during the CIP, to eliminate the yeast also, the wild yeast also. But yes, after the CIP, we have to ensure that the CIP, whatever the water we have used or the effluent we have used, to be properly drained.
So the next question comes up that which type of fermentation we use sulfur-free test?
We can use sulfur-free tests in syrup fermentation, juice fermentation, and molasses fermentation. So in any of these three, we can use it.
And so another question from the chat has come up that which analysis method is reliable at plant level for SO2 measurement?
Sir, as I mentioned it during my discussion on the measurement methods, UV spectrophotometric method is more reliable and it is not very cost intensive, where we no need to invest so much of amount on it. The spectrophotometers will be UV visible spectrophotometers will be affordable at the plant level, as well as it gives us more accurate at ppm levels also, and it is easily adaptable. With a little bit training, we can replicate this and we can use it at the plants. So UV spectrophotometric method is more reliable in the plant scenario.
So the next question from the chat is, what are the normal levels of sulfide that you have encountered in a typical BH and CH molasses from a sulfitation sugar plant?
Sir, it will be a tricky question. Normally, how much it should be, because there is no such limit how much it should be in the molasses or anything. But when it comes to the fermentation, preferably if the final amount or final concentration, if it is below 100 ppm, that would be good.
So another question is there any possibility of sulfide carryover from cane? If yes, what parameter should be analysis?
Sorry, can you please come again?
Yes, if there is any possibility of sulfide carryover from cane, if yes, what are the parameters to analyze it?
Sulfite coming from cane is not possible, because the sulfites cannot be produced inside the plant. So if it is coming in the system, means either it is coming from the ingredients which we are using or from the sulfitation process. So we can use the spectrophotometry method to analyze it.
Many of the questions are much more covered by Dr.
Yeah.
Park. And
yeah, I will read another question. In the case of syrup fermentation, syrup is directly used in process, then where we dose the sulfur-treat. In case of molasses, fermentation can be able to use this in molasses storage tanks. So instead of using it in molasses tanks, we would suggest to use it during the dilution process if possible. That is the best method, because if we try to use it in the molasses storage tanks, the recirculation, other things will be a problem. Dosing of the product would be a problem. So if we use it in the molasses dilution process or maybe during filling, it will be more helpful. And if we are taking syrup directly into the fermentation, yes, during filling we can add it. Next question is, how can we reduce the sulfur ppm levels before fermentation process? So as I discussed in my presentation, we can use certain upstream mitigation process, like reducing the sulfide dosing or ensuring the sulfide streams are not coming into the fermentation. Or in case if it is coming more, then probably we can use the products like sulfur-treat to reduce the sulfite levels, sulfur levels in the fermentation. Next question is, could you share the method for sulfite analysis? Yes, we will share that. Is SMBS used useful during fermentation process as like other nutrients, urea, DAP, magnesium sulfate? No. SMBS is not useful as a nutrient, but it is useful as a disinfectant, more preferably in the CIP process. Is it harmful to the use yeast cell in the form of gas or in the form of complex SO4? It is more harmful when it is in the form of gas. Can we use sulfotreat at molasses runoff tanks while the production of molasses inside the plant? No, it is not suggested at that time, as the temperature and other things won't be favorable for it. Is there any possibility to control the sulfur levels during sugar process? Yes, definitely it can be done. You people are more experts in this, in the sugar manufacturing process. What we have to do is we have to ensure the dosage or the sulfitation concentration which we are using is used as per the process conditions, and then proper neutralization after that. After sulfitation, if we do proper neutralization with lime and other stuff, then these levels can be managed.
We are close with the queries and the questions. If you have any, you can mail us and we would be eager to answer them if it is there. And we are also hoping if you have any plan sessions or audits that are required, do let us know or contact us to our official website or email ID or the phone number. We are available for you. Thank you so much for the joining. And really, we appreciate your time and the efforts that you have come up and joined the session. And we really appreciate our speaker also. Thank you so much, Dr. Pawan, for giving this great idea about sulfite, its insights about the plant, and overall how we can really help as the team Catalyst group to curb this out. We really appreciate your efforts, sir. Thank you so much. Thank you so much, everyone, for giving your time to this webinar. We really appreciate that you've got that knowledge, and we hope that you come us and help us out and get it into our clients list. And we really appreciate your time. Thank you so much.
Thank you all.